Okay, let's take a look at our first example, and we're going to see if there is a correlation between the amount of hours that someone studies for the math EOC and their EOC score. So pretty much what we're taking a look at, if we increase our hours of study, will our grade go up? Will it increase? You can see these data points have been plotted, and here are the data points listed in our table. And so we are going to use our TI calculator to find our line of best fit. And you can see the line of best fit is already been sketched into our graph. So now we're going to learn how to use the calculator to find that line of best fit. Okay, so let's take a look at our TI calculator, and let's remember how to clear the memory. So we go second, 0, 2, and we've cleared the memory. Now, just like with univariate data, we're going to insert our data using the data key. So click data. Now, because we're working with bivariate data, we're going to have list 1 and list 2. List 1 is going to represent our X values, and list 2 is going to represent our Y. So they will be ordered pairs. So I'm going to enter my ordered pairs of our data of how many hours. So someone studied 2 hours, 6 hours, 6 hours, 5 hours, 3 hours. Someone else studied 3 hours, 2 hours, 1, 4 hours, 4 hours, 0 hours, 3 hours. Someone studied 5, 1.5 hours, and 4.5 hours. Now, we have to be super careful when we enter our Y values in list 2 to make sure it matches up with that X value. So the person that scored or studied for 2 scored a 75. So our output are the scores, our inputs are the hours. Then we have a 95, 92, 94, 82, 86. Then we have 78, 71 for somebody that studied 1 hour. We have a 94, a score of 90, a score of 60 who studied 0 hours, a 79, a 98, a 74, and lastly a 90. So I just make sure that all of my X's and Y's from list 1 and list 2 line up. Now we can find our line of best fit. So we are, again, just like with univariate, we're going to go to second stat, but this time instead of 1 variable stats, we're going to go to 2 variable because we're working with 2 variables. Then our X data is in list 1, our Y data is in list 2, and then we want to calculate. Now this is going to give us all that we need. So again, we can see that the average hours of study is 3.3. We're going to scroll on down, and we are looking for the little a. So see where we have the big D. Okay, so that's line D. The little a is going to be your slope for your line of best fit. So we will probably always round to the 10th unless otherwise noted. So we have an a value of 5.6. That will be your slope, your m in slope intercept form, with a y-intercept of 65 point, and we will just round that to 65.1. We may even round it to 65. So that is your line of best fit. Now, while we're here, let's go ahead and just look at the next line down, that line F. That little r is your correlation coefficient. We will talk about that in just a few minutes, but I will tell you that value lets us know how strong our line of best fit is. Does that equation y equals 5.6x plus 65, does that represent our data points really well, strongly, or not? And so again, A is your slope, B is your y-intercept, and R is your correlation coefficient. Okay, let's do a recap. Step 1, you're going to enter your data values into list 1. Again, you're going to click data. You're going to put your x values in list 1. You're going to put your your y values in list 2. So list 1 are your x's, list 2 are your y's, and then your ordered pairs should line up. Step 2, you're going to click second stat, and then instead of one variable, you're going to click on the two variable. You're going to make sure that list 1 is highlighted for your X data and list 2 is highlighted for your Y data. And it should default to these highlights. Then you're going to click Calc. Then you're going to scroll down using your arrow buttons and you want to locate the A, the little a right here, which is line D. Okay, these are the 3 lines you're looking for. Remember, we're trying to find our line of best fit, our linear regression model. So we have A is your slope, okay? E is your initial value, the initial score when you have studied 0 hours in this case. And line F, the little r, is your correlation coefficient. So we should write a little f here, or big F, I should say. So line D is your slope, E is your initial value, and F is your correlation coefficient. But you don't have to memorize that. You just have to know that A, which is our M for slope, B is your y-intercept, and R is called the correlation coefficient. So here is the model. Here was our slope. We rounded to the 10th, and here is our initial value. So when we study 0 hours, we start out with a 65. And then each additional hour we study, we go up 5.6 points. So X is hours of study, remember, and Y is your EOC score. So the more that we study, the higher we make on the EOC. So now we are going to make some predictions. So we're going to predict the score after studying for 2.5 hours. So we are going to input 2.5 and see what we would make if we study for 2.5 hours. Now, 2.5 hours is in that range of our data. So this is going to be interpolating. So I'm just going to quickly calculate this. And it predicts that we would make a 79 if we study 2.5 hours. This is the point of our line of best fit, is to be able to make predictions. So once we create our line of best fit using our calculator, we can use it. Okay, what if we study a half an hour? So we're going to calculate this. So we have 5.6 times 0.5 plus the 65. And it says we're going to make a 67.8. We will round that to a 68. So we can see that the more hours that we study, the better we make on the test. Now let's take a look to see how many hours it would take if we wanted to make a certain score. So this time we are given the Y, the EOC score, and we're going to find X, the hours. So we're simply going to plug in the score of 100 and see how many hours using our line of best fit that we need to study to make that goal of 100. So we're just isolating x, and then we are going to divide 35 divided by 5.6. And this is 6 point, and I'll go ahead and be more specific, 6.25 hours. So this data is outside of the range of the data values that we had when we collected the data in our survey. So this would be called extrapolating the data. Extrapolating. Looking at data outside the data points that we were given. Okay, now let's see what we would make or how many hours that we need to study if our goal is a 91, which is within the range. So this is going to be interpolating the data, looking inside the data values that are given. So we want a 91. We plug it in for the y, and we solve for x. This is why I always like to identify and represent or acknowledge what our X represents and what our Y represents. This will help you answer questions. So now we're going to take 26 and divide it by 5.6. So it says 4.64 and so on, but we'll just round it to 4.6. So to make the 91, according to our line of best fit, we need to study for 4.6 hours. Now let's take a look at correlation coefficient. So our correlation coefficient, remember, was the little R value. And when our R value is positive, like it was in our example, then we have a positive correlation. If the value were negative, we would have a negative correlation. So the range of correlation coefficient is going to be between -1 and +1. And then we have all these values. If we had a correlation coefficient of 1, that means we would have a perfect line of best fit, meaning all of our data points created an actual straight line and they would not be scattered at all. If we had a perfect -1 correlation coefficient, then our data points, our scatter plot would look something like this in a perfect straight line. And this is what it would look like if we had a correlation coefficient of +1. So 0, of course, or anything near the middle is going to tell you that there's no correlation and your line of best fit is not very useful at all because there's no correlation and it's not strong. And so we look pretty much, if we have the range, if we're on the negative end, so for a 0.8 to 1, negative 0.8 to -1, or on the positive end from 0.8 to 1 is a very strong correlation. And then we do have correlation, from like 0.5 to up to 0.8 and in between. There is a correlation, but it's just not very strong. We would call it weak. So here are some examples. This is what I was talking about. We have a perfect negative correlation. That would be -1. This would give us, this is a strong negative. So, this probably would be maybe like 0.9 something, 94. And then we get a little bit weaker, but we still have a correlation. So this might be, zero point 0.7, 0.75. And then this is the example of no correlation. And then we look at the positive end. Okay, so let's go back to our correlation coefficient was 0.94. And I'm going to describe this as a strong positive, meaning that we can pretty much count on our linear regression model, our line of best fit, to make good predictions. It is a reliable line of best fit. So there is a strong relationship between the hours that we study for the EOC and the score that we will make. With the correlation coefficient, I'm generally going to always round to the nearest hundredth. So just a review. When you go to your calculator, your little a value that's on line D is your slope, line E, B is your y-intercept, and line F gives your correlation coefficient value.